What if I told you there's a robot that can walk like a human, change its legs when needed, and then start rolling like a machine on wheels? Sounds hard to believe, right? Probably still feels like science fiction to you, but I'm about to clear that illusion. Because this is Tron, a next-generation biped robot that's quietly changing how researchers think about movement, balance, and artificial intelligence. And today, I'll show you why Tron is different, what it can actually do, and why robotics labs around the world are paying close attention to it. Tron, also known as Tron 2, is a humanoid-style research robot built specifically for advanced robotics experimentation. This is not the kind of robot that cleans your house or replaces humans. That's not what it was designed for. Instead, Tron is built as a test platform robot engineers use to experiment with and improve how machines move, whether that's walking logic, balance systems, AI-driven motion, or real-world mobility challenges. Simply put, it's a complete robotics laboratory brought to life on 2 legs. And don't leave the video just yet, because the most impressive part is still coming. As you probably know, most biped robots are limited to a single walking style, but Tron breaks that barrier. Thanks to its modular lower leg design, engineers can swap its feet depending on the experiment, using a point foot setup for balance testing, a flat sole for human-like walking, or even a wheeled configuration for rolling movement. This flexibility allows researchers to study how one robot adapts to completely different environments without rebuilding a new robot every time. Walking may feel effortless to humans, but for robots it requires constant balance correction, instant feedback processing, and extremely precise motor coordination. That's exactly why Tron is engineered to recover from small disturbances, adjust its posture while moving, and test AI-driven motion strategies, making it a strong bridge between controlled simulations and unpredictable real-world movement. And because Tron isn't just advanced hardware, but also a software-ready platform that works seamlessly with modern programming frameworks, simulation tools, and learning-based AI models, developers can train walking behaviors in virtual environments and then deploy them on the real robot faster and more safely. This is why Tron has become especially valuable for universities, robotics startups, and AI research labs. Tron doesn't try to impress with flashy demos, because its true value isn't in how it looks, it's in what it can do, and that value will become even more clear in the years ahead. Research on robots like Tron is essential for the future of robotics. It helps enable better humanoid robots, smarter prosthetics, advanced search and rescue machines, and future robots that can safely operate around people. So even though Tron may not be coming to your home anytime soon, it's shaping the robots that eventually will. If you enjoyed this deep dive into real robotics, hit like, share, and subscribe, and let me know in the comments which robot you'd like to see next.